Okay, this video is for the Learning Target 4 notes, which is basically adding and subtracting fractions. It's just that your fractions will now have monomials or binomials or trinomials in the numerator and the denominator. So that has a new name. It's called rational expressions. That's what this whole unit's about, rational expressions. So quickly, I'm not going to read to you the steps. These steps are things that you've done with fractions all your life. You've got to get a common denominator, then you add the tops of the fractions or subtract them, but you don't change the denominator, all those things. So number one, the old stuff. To add fractions, when they have a common denominator, you just add the tops, 14 over 16, and then sometimes, like this example, they share a 2, so you can reduce that 2, so your final answer is 7 over 8. In example 2 here, when the denominator is 5 and 6, you'd first have to find the common denominator, which is 30, and change them both to fractions with denominator 30. So that would require you to multiply the 1 over 6 by 5 over 5, which would make 5 over 30. And it would require you to multiply the 4 over 5 by 6 over 6, giving you 24 over 30, and then you subtract the tops to get 19 over 30. I'm not going to do number 3, but it would be much harder to do number 3 unless you saw the factors 2 times 13 and 3 times 13 to find your common denominator, which would be 2 times 3 times the shared 13. Okay, but now, for our unit, much is the same. The rules for adding and subtracting fractions is the same as they've always been. So in number 1, to add fractions, you look at the denominator. Are they the same? Yes. So step 2 would say, add those. I don't want to say step 2 without looking. Step 4, sorry. Because if the denominators are the same, then you go down to step 4. Now add or subtract the tops. So that would be 5 over, leave the denominator the same, so 5 over a, and it doesn't reduce. That's your final answer. Example 2, the 2a and the 5b denominators are not the same, so you need a common denominator. So C number 1 on the previous page means look at the notes from the previous video. And number 1, the common denominator between a 2a and a 5b is a 10ab. So we go back and use the denominator 10ab. So I need both fractions rewritten with this denominator. So we'll need to multiply the first fraction by whatever it takes to turn 2a into 10ab. Well, we need a 2 times 5 to make the 10. We've got an a, but we need a b, so we're going to multiply this by 5b, top and bottom. So the bottom becomes 5 times 2, 10, a times b. The top becomes 5b times 5, 25b. Second fraction, that 5b needs to turn into 10ab, so we multiply it by 2a. And that gives you 6a in the top. Now we are at step 4, which says you got the common denominator, so add the tops. Well, 25b and 6a are not like terms. So when you add the tops, the numerators, you can't really add them. You just have to write them as a binomial. And then keep the denominator 10ab. Then we want to consider 25 and 6 and b and a to see if there's a GCF to pull out that might reduce, but there's nothing that does. We'll see that happen in the next problem. So number 3, looking at the denominators, they are the same, so just subtract the tops. So that would say 2x minus 2. You cannot combine those, they're not like terms, over the common denominator x minus 1. But now we consider, is there anything we could factor out of the numerator? Yeah, there's a GCF of 2. And if we take that 2 out, watch what happens. You have a factor of x minus 1 and a factor of x minus 1 in the denominator that reduce to 1, leaving you with 2 times 1 over 1, leaving you with the answer 2. The next one's kind of weird. It really is. This one's kind of a one-trick pony, but the x minus 5 denominator and the 5 minus x denominator, if you think about it, like put a 1 in for x. 1 minus 5 is negative 4. 5 minus 1 is 4. Those denominators are almost the same. It's just the opposite sign. So if you factor out a negative 1, in either of the denominators, which I'll choose to take it out of this denominator, it changes the 5 to negative, changes the negative x to positive, so it makes it x minus 5. Now you have an x minus 5 denominator, another x minus 5 denominator. That negative 1 simply turns the addition problem into subtraction. So we have 3 over x minus 5. The negative 1 goes in front of the fraction, turns it into subtraction, and it says 1 over that x minus 5. So the addition problem turned into subtraction, and we have common denominators. So 3 minus 1 turns into 2 over the common denominator x minus 5. And then the last two. Number 5, what's the common denominator between x plus 1 times x plus 2 and x plus 1? Well, they share an x plus 1, so you need to use the x plus 1 and the leftover x plus 2, which means the common denominator is x plus 1 times x plus 2. All right, now that I've got that, the first fraction, well, it already had that denominator, so we don't need to change it at all. But the second fraction only had the x plus 1 factor, so it needs the x plus 2, so we will multiply the top by x plus 2 and the bottom by x plus 2. So now it says 2 times x plus 2. Sticking with our rules of fractions, we subtract the tops and keep the denominator the same. So 6x minus 2 times x plus 2 divided by x plus 1 times x plus 2. Now we will distribute and combine like terms in the numerator, crossing our fingers, hoping to maybe find a factor of x plus 1 or x plus 2 that might reduce. I don't know that it happens, but let's see. When you distribute that negative 2, you get negative 2x minus 4. To combine the like terms, 6x minus 2x makes 4x minus 4. There's your numerator over x plus 1 times x plus 2. And we almost got a factor. If you think about it, see the 4 and the 4? If you took the GCF out, 4, it would leave x minus 1, which is almost the x plus 1, but it's not. So we can't reduce this any further, but it's definitely worth thinking about. In your head, it's worth factoring that 4 out, thinking, all right, that's going to leave me with an x minus 1, because it might be an x minus 1 in the denominator that you can cancel. Okay? Last one, number 6. It's the most like the homework. For starters, the denominators, x squared plus 5, x plus 6, and x squared minus 9, we've already found that common denominator in video 3. So we go back. The common denominator was x plus 2 times x plus 3. I'm sorry, x plus 3 times x plus 2 times x minus 3. All right, put that to use. All right, I think I might need to extend the page a little bit. It's going to be kind of tight to write this, so bear with me. Common denominator is x plus 2 times x plus 3 times x minus 3. And we need one more denominator with that, x plus 2, x plus 3, x minus 3. Barely got it in there. All right, so looking at the first fraction, it already had an x plus 2 and an x plus 3. So what does it need? It needs the x minus 3. So multiply the top of the fraction times x minus 3 and the bottom of the fraction times x minus 3. And you get 2 times x minus 3. Looking at the second fraction, the denominator already had x plus 3 times x minus 3. So what's it missing? It's missing the x plus 2. So multiply it by x plus 2 in the top and by x plus 2 in the bottom. So we get 3. Whoops. So we get 3 times x plus 2 in the numerator. Add your fractions. The rule says add the tops, but leave the denominator alone. So x plus 2 times x plus 3 times x minus 3. And then adding the tops, I'm going to go ahead and distribute 2x minus 6 and distribute 3x plus 6 and add those. 2x and 3x makes 5x. Negative 6 and plus 6 when added cancel or reduce to 0. So 5x is our numerator. Does 5 or x, the factor 5 or the factor x, appear in the denominator? No. So we're done. That's the final answer. And that's all for Learning Target 4.